Okay, good evening everyone. Can everybody hear me? Okay, so hi, my name is David De Winter, and I'm going to give you a presentation about what our company OTA Insight does from a data science perspective. First of all, a short introduction about myself. So I graduated 2 years ago from Ghent University with a master's in computer science and business economics. I already have a working experience in developing recommender systems during my time at Solbase, which is a startup here in Ghent. Afterwards, I started full-time at Massive Media. They're most well known for their former product, Netlog, and nowadays they're still popular with True, one of the biggest social discovery sites / dating sites in the world. There I've been working on implementing batch data pipelines, and I was also working on evaluating A/B tests, doing data analysis, and a lot of performance monitoring tools. And but at a certain point, I realized that I wanted to be part of an early stage startup where I could have a big impact and build things from the ground up. And that's why I decided to jump ship about 7 months ago to OTA Insight. So the last 7 months I've been mostly working on our streaming data pipeline architecture, which is cloud-based, and now I'm also more advancing into predictive modeling. So who are we? Well, we're a startup in the hospitality industry. Our clients are hotels, chains. Our software is used by revenue managers, and this is around a €1 billion market. And our company came into existence in 2012 by our 3 Belgian co-founders. They saw a lot of opportunities in this market, and now we already have offices in London and Ghent. In Ghent, our development team is located, and in the past year we've experienced significant growth. Our customer base has multiplied times 5, and our team has expanded from 10 to over 30 people. And as of right now, already 4 out of the 10 largest hotel chains are already rolling out our product. So what is exactly the problem, the context, the need for our product? Nowadays, revenue management, which is basically strategic control of hotel room reservations, is becoming increasingly more complex. Ideally, a revenue manager wants to sell his hotel room reservations at the right price for the right customer and at the right time. Now, there's 2 factors that attribute to that, to the fact that it's becoming increasingly more complex. So on the one hand, there's the market, which is more dynamic and is generating more data than ever before. This is more, due to the power of online travel agents nowadays. An online travel agent is someone like Expedia and Booking.com, which is basically the middleman when you're booking a hotel online, or at least that's what they want to be. These online travel agents have so much power that they enforce hotels to obey certain parity requirements, which means that a hotel must guarantee that across all distribution channels their lowest rates are equal, so they're not allowed to offer lower rates on their own websites. And also, they ask increasing distribution costs. They can take up to a 30% commission on a single booking, which is quite significant. And on the other hand, there's consumers. They have easy access to the price and the value info of the market. So there's price transparency. A customer can easily see online the prices of every hotel, and this also leads to the fact that there's a decreased loyalty for hotel chains. And nowadays, consumers also tend to book shorter in advance, which makes it also more difficult for revenue management. And another important aspect is the online reputation and rankings. By rankings, I mean the position that hotels have when you're searching on online booking sites. These can have a very big impact, along with reviews of users in the price sensitivity of your hotel rooms. So how do we make the life of the revenue manager easier again? Well, basically, we aggregate publicly available data from online travel agencies, and we combine it with internal hotel data. We then transform this data by using our proprietary algorithms to turn it into actionable analytics. And ultimately, what we want to do is help hotels use these analytics to grow our revenue online. So now I'll quickly go over the product features that we offer. So first thing is rate or price intelligence. So we make sure that hotels can easily monitor all their rates across different distribution channels for their own hotel, but also for competitive hotels. Next up, as I said before, the rate parity. We make it easy for them to see in the blink of an eye if there's any parity breaches that could cause valuable revenue loss. Then another important aspect, as I said before, the ranking and review analytics, we relate them to their OTA performance. And then one of the more valuable things, which is pretty unique, based on our competitors, is our demand forecast. So we have a forecasting algorithm which tracks, in fact, all the in-market online inventory to give you visibility of future market demand of the next 90 days. So the demand is predicting how busy days are going to be within the destination that your hotel is located in. And a factor that can have a big impact on the demand within a destination is an event. It is of the utmost importance that hotels can quickly detect if there's new events within their location so that they can respond to this. We make it easy for them. So how do we enable all of this? Well, we have 2 years of historical market data powering our predictive algorithms, and we ensure we get quality data by our data acquisition platform, which I'll go into detail in the next slides. But first of all, let me show you a relevant data analysis that one of our data scientists has done in the past week. So this is, you can see here on the two graphs, it is the price impact of the Paris and Brussels terror attacks. So the arrival date here, it's only Saturdays. Saturdays are especially important for leisure travelers. Here the impact is the most visible. That's why we've chosen Saturdays. So what you can see is the arrival date plotted against a lot of different metrics, such as the occupancy of the hotel rooms, also the revenue per available room, which is the total revenue divided by the number of available rooms, and the average city rate. What you can clearly see is, so the two vertical dotted lines, the first one is of course the Paris attack, which occurred mid-November, and then we also have end of March, the Brussels terror attack. So what you can see is during the occurrence of both events, the average city rate remains the same, but we can clearly see a significant drop in the revenue per available room and the occupancy. You can clearly see that after the Paris attacks, the revenue drops 30%, and this is definitely not a seasonal trend, as the graph in the bottom shows, which is the relative difference for Saturdays compared to last year. You can see that the relative difference is a bit like 50% at a certain point, so they lose 50% revenue compared to last year. And this downwards trend lasts for like 2 months until around mid-January. Then it aligns with the results from last year, but then again, when the Brussels attacks strike, there is a significant blow to the revenues gained again, with up to minus 75% at the beginning of April. So now I'll go into the technology details. So how do we realize all of this? Well, a major part in this is leveraging the Google Cloud platform. So the Google Cloud platform is basically the counterpart to Amazon's web services. And it's been gaining a lot of traction recently, especially since the acquisition, since the announcement that Spotify is transitioning to the Google Cloud, as well as Apple for their iCloud. It really saves us a lot of hassle. Some people coin it the no-ops model in contrast with the DevOps model. So what this basically means is that the environment is so automated and the underlying infrastructure is so abstracted away that you don't need a dedicated technical team to manage your software in-house. So we don't actually have a dedicated systems engineer. Every data engineer and data scientist in our company basically just spins up their own virtual machines, does the little configuration that is necessary to get everything working. So there's no worries about capacity, reliability, and performance. And this allows us to really focus on our core activities, which is providing real-time analytics. And in the bottom half of the slide, you can see our architectural overview, which I'll go into more detail about in the following slides. So basically, you can divide it in three distinct parts. So first off, we have our data acquisition. This basically consists of us retrieving on a daily basis around 150 million rates. We built a framework on top of scraping to do this. We retrieve this from online travel agents, global distribution systems, but also meta search sites like Trivago. We do this via formal and informal agreements via various protocols during different timings of the day. To ensure we have completeness of our data, there's integrity checks for every request. So only after all integrity checks have been marked completed do we calculate our derived metrics and push them to the app, to our users. So once we've retrieved our data, it's pushed into our distributed queues. We use Apache Kafka for this, which is a high throughput distributed messaging system. What it basically does is it decouples our data pipelines so we can handle varying loads on our cluster. Kafka is very fast. It can allow reads and writes of up to hundreds of megabytes per second. It's scalable and it's very durable as the data is stored on disk, which minimizes any data loss. And the Google Cloud services that we use for this step are Compute Engine. Compute Engine is an infrastructure as a service. And we also use Google Container Engine, which allows us to launch Docker containers. Then next up, our data transformations phase. So for this, we consume all the different Kafka queues with various data, and we transform it in our Spark Streaming Transformations framework. So we basically convert our unstructured data to structured data according to our own proprietary formats. So a little explanation about Spark. Spark is seen as the successor to Hadoop MapReduce. It does in-memory data processing, so it's very much suited for streaming data processing. This whole data transformations framework runs on top of Dataproc. Dataproc is basically a managed Hadoop and Spark service, and it allows us fast and scalable data processing, easy management and monitoring, and it also integrates very well within the cloud platform. Once our data has been transformed to our own format, we save it in Bigtable. Google Bigtable basically covers most of our storage needs. It stores 50 billion historic rates of the last 2 years, which is several terabytes, which is stored on SSDs. Bigtable is a scalable NoSQL database service. It's very much different from a relational database in a sense that it's basically a multi-dimensional sorted map. And it offers us a really consistent low latency, and it's fully managed, and you can easily scale it without any downtime. And it also comes in a certain way with a fixed cost. So once we have to do any data analysis, custom data analysis, it's really easy for us to scale it up by just purchasing or adding extra nodes to it to increase our throughput. And then one more crucial aspect, once you have all these different components within your infrastructure interacting with each other, you definitely want to make sure that your logging is in place, because if all hell suddenly breaks loose, you want to be very quick to solve it and anticipate problems. And for this, we use Google Monitoring. Here again, it has easy integration with all the rest of our services. You can easily set alerting policies to notify you via email or post messages to Slack. It already offers out of the box a lot of standard metrics about all the Google services that we use, but you can also define custom metrics. And all of our engineers can also create custom dashboards so that they can easily monitor the components, the systems that they're responsible for. Now, some of you probably think that I'm just here doing a promo talk, that I somehow get a commission out of this. This is not the case. Overall, we're very satisfied with Google Cloud, but it isn't the holy grail yet. So some remarks. There's a lot of beta labels, so they don't offer any real guarantees. And at one point, not too long ago, we also had a 1-month notice of significant breaking API changes, which caused quite a headache. And then there's also been a couple of billing issues where some services suddenly tripled in costs, which was quite a shock initially and a time waster. And a few weeks ago, we also had a couple of outages of around an hour. So that's also a bit unpleasant, but overall, we're quite satisfied. And then one of the last slides, so some of our data science challenges that we're currently working on. I can't go too much in detail, as our competitors are also listening in, but a major focus are price optimizations. So eventually we want to do price suggestions, but there's a lot of things to solve, a lot of challenges to tackle. One of them is room type mappings. So ideally what we want to do is identify similar rooms across various hotels and also across different distribution channels. But the problem is that all of these different hotels have different namings for their rooms. So a double room can be just a double room for one hotel, but another can be double deluxe room or whatever. And yeah, that's basically the issue. Then there's also the impact of events on prices. So as I said before, it's very important to anticipate new events so that hotels can take advantage of this by hiring their prices if it's very impactful. Then there's also hotel matching, so identifying the same hotel across different distribution channels. And we're also constantly trying to improve our market demand forecast by using more data sources. And then one more example to show the importance of an event detection. So last week we were doing some analysis and we suddenly saw a strange outlier. So these are the median rates in Brussels per time stamp, per extract date. So what you can see here at the end of April, there's a significant spike which caused the prices of hotel rooms to triple in Brussels, and we were really wondering, how is this possible? Is this some kind of mistake? And so what did we do? We combined it with our events calendar, and what did we see? Apparently there's a seafood fair happening in Brussels. Yeah, so this shows the importance of event detection for a revenue manager and responding quickly to this and taking full advantage of it. So thanks for listening. Are there any questions?
It's scraping to scrape the websites, but what happens if, for example, Booking.com change their entire UI?
Yeah.
Does that mean that you can you do a couple of hours or days their data? Or?
Yeah. So the question is, what do we do if a hotel, if a booking website decides to change their layout? Well, it depends on the way we retrieve the data. We do not scrape all websites. With some of them, we have formal agreements. We use JSON APIs and whatnot. But if that happens, we try to minimize the downtime and get one of our engineers on it who tries to fix the problem as quick as possible. Yeah.
For your predictive analytics, what do you use for that?
As I said before, I can't go too much into detail about that, but you can ask one of our engineers at the drinks.
But you can say if it's Google or if you use R or if you use
Okay. The backend is written in Python, if that's what you mean. Yeah, and it's all on the Google Cloud Platform. Yep.
How do you manage the legal issues with scraping websites? Because I can imagine like you might have some formal agreements, but some people like. Also, do you first ask or do you first break? Like.
It all depends. So with some of them, as I said before, we have formal agreements. Others we don't. So then we use proxies. But we really try to reduce the rate by which we crawl. So we're pretty friendly in that ways. We've heard a lot of bad stories about that, but we try to make sure not to overload their systems. Yeah. Okay.
How do you get to the event data? Do you use it from your hotel data, or you have external sources? Or?
We use multiple external sources. Yeah.
Do you take things like Airbnb into account?
Not yet, but we're considering it. Yeah, it's on our roadmap.
Has the price of hotels in Germany, for instance, increased while here decreased? Do you see the movement of people to get out of Brussels and go somewhere else?
Yeah, as I showed, there's been
prices increased in some other places.
It could be. We haven't really looked into that in detail. I'm not sure about that specific use case. Yeah.
Where did you get the revenue data from?
We use internal hotel data. We don't have it from all hotels, but we do have it from a lot of them.
If you have two hotels which are a customer with you, do you take the revenue data from one hotel and expose it in the other, in the average show to the other?
Yes, we do. Yeah. But only general metrics, of course. We don't go into details because otherwise they won't share it with us.
Can we use your tool if we want to book a hotel?
We only offer a B2B solution, but we've already thought about offering a B2C solution as well, but then we might scare away existing clients. I mean, yeah, you have to choose one side.
How is your own revenue model? Is it based on percentage price increase or
It's a monthly fee.
It's monthly fee
Yeah.
per room?
No, it's a fixed monthly fee. Doesn't matter how big your hotel is.
Okay.
Yeah.
Are you taking account that people might look at a hotel room more while the price rises because the hotel sites or the booking.com sees that you visited that booking for 5 times already?
I don't think, I'm not sure, but I don't think Booking raises the prices based on cookies and page visits. We don't really track that. Yeah.
How do you measure your own business impact? Like, what kind of difference do you make for your
well, a lot of hotels that are customers with us have already done studies on what the results are of using our tool, and they really have increased their revenues, their profits by quite some significant margins. I don't know the specific numbers, but a lot of them are very happy that they use our tool. Yeah.
But how do they increase the revenue? By increasing the price of the room, or what do they do with your data?
Well, they look at the market, how the market currently is, how busy it's going to be. If there's new events occurring, they can easily increase their price if they know they're going to be fully booked. Things like that. They have different strategies. Yeah. Okay. Yeah, that's it. Thank you.
Hey, I hope you liked this presentation. This presentation was held in the Brussels Data Science Community Meetup. If you want to know more of when these meetups are taking place, just check the link below. Bye-bye.